The second target in our matter unit after the density target is analyze different types of matter in terms of structure and organization. And in order to do that effectively, we first have to learn about the different types of matter, and we're going to do that by filling in this chart. To begin, all matter is made up of mass and takes up space. From there, they separate into two categories, pure and unpure matter. We're going to start with pure matter first. Pure matter are also known as substances. And this is matter that cannot be physically separated. What this means is that they can be separated, but you have to use chemical separation. There are two types of pure matter. The first are elements, and this is matter made up of one type of atom and is the simplest form of matter. These are easy to identify because not only are they the things in the periodic table of elements, they also have a symbol that only has one capital letter. So, for example, you can look at the periodic table of elements and pick any of them. But for now, I'm going to pick helium. And right here we have one helium atom. The second type of substance we have is a compound. And this is matter made up of two or more different types of elements. That are chemically bonded. These are also easy to identify because they're going to have chemical formulas. Which means they're going to have more than one capital letter. And for our example, we're going to go back to our really basic ones. We have water, which is made up of two hydrogen atoms and one oxygen atom, and table salt, which is made of one sodium atom combined with one chlorine atom. So when we draw it, we draw a compound with these chemical bonds in between the atoms. So there are two types of pure matter, elements and compounds, and they can't be physically separated, but they can be chemically separated. The other type of matter is unpure matter, and we call those mixtures. These are the things that can be physically separated. What do I mean by physically separated? This means I can use a magnet to separate out pieces, or I can use evaporation, or I can filter pieces out, or I can take the densities of individual substances into consideration and use that, like in our density tube, to separate out pieces of a mixture. There are two types of mixtures. There's homogeneous and heterogeneous. Now these are Greek roots. Homo means same. So this means that a homogeneous mixture is an evenly mixed mixture where all samples are the same. And that's where that homo part of homogeneous comes in. Heterogeneous, hetero means different. So a heterogeneous mixture is an unevenly mixed mixture. Where all the samples are going to be different. But let's go back to homogeneous. There's only one type of homogeneous mixture, and that's called a solution. And a solution is a clear liquid that you can see through. So, for example, Windex, or that blue window cleaner, is an example of a solution. All the samples of that would be the same. And Kool-Aid is another example of a solution. And we can physically separate out like Kool-Aid from the water and the powder by using evaporation. So that's why it's in our mixtures category. Whenever you think of a homogeneous mixture, you should think of solution because they can be used interchangeably. Heterogeneous, however, has two different types of mixtures. First is a colloid, and that is an unclear liquid or gas that scatters light. So some examples of this are milk and fog. So when you're driving, you have something called fog lights on your car, and those lights are lower than your normal headlights, so they can go underneath the fog. It's actually really dangerous to drive with your brights on in the fog because the fog will scatter the light back into your windshield and the windshields of others. Fog is definitely one of the more dangerous colloids we have. The other heterogeneous mixture is the suspension, and these are really easy to identify. They're uneven mixtures that separate into layers. So, for example, oil and water is a suspension because the oil is on top of the water. Another good example is our density tube, where we put all the liquids from our density lab into the same tube and they separated into layers. A more common example of a suspension in your life are bowls of cereal, because the milk and the cereal separate out. Eventually, you're going to be asked to identify between solutions, colloids, and suspensions. Suspensions are really easy to determine. However, solutions and colloids sometimes can look the same. So in order to differentiate between those two, we use something called the Tyndall effect. We use a light source and we put it up against a solution and a colloid. As you can see, in a solution, there's no scattering of light, meaning I can't see a beam. It may glow a little bit, but I'm not going to see a distinctive beam. However, in a colloid, you'll see that there's the beam of light right here. So when we do a lab and we're wondering if it's a solution or a colloid, we're going to use the Tyndall effect. So a solution, we say, fails the Tyndall effect. While a colloid passes the Tyndall effect. So again, if it passes the Tyndall effect, you're going to see a distinctive beam of light in a colloid, while you will not see that in a solution. On the back of your note sheet, we want you to fill in this flow chart. This is going to help you immensely when we start our determining liquid mixtures lab. So for example, you're going to start here, and if your mixture is separating into layers, yes, then it's going to be a suspension. Again, those are really easy to identify without the chart. If it's not separating the layers, then it's either going to be a colloid or a solution. So is it an unclear mixture? If yes, you should try the Tyndall effect. And if it passes, then it's a colloid. If it doesn't, then it's a solution. If it's a clear mixture, then it's more likely a solution, but you should still probably test the Tyndall effect in addition to seeing if it's clear or unclear.